In this video, we're going to take a look at the concept of half reactions. So in the previous video, we saw the idea of something being reduced and something being oxidized. What we can do is we can go and analyze each part of the reaction, the oxidation part and the reduction part. So what we're going to do is we're going to take the overall reaction and we're going to break it up into its two parts. There's a few ways you can do this. You can take the overall reaction. You can also take the net ionic equation, and you can separate them into the half reactions. So we're actually going to do the net ionic equation because that's usually a better approach. So we've already done the overall, but let's take the overall net ionic equation. So we're going to do the Ag. What was our net ionic? Let's go back up here to our example. It was Ag plus, there's two of them, aqueous plus Cu solid produces some 2Ag solid plus Cu2 plus aqueous. Now what we're going to do is we're going to take the oxidation part. So we concluded that the copper, when the copper 2 plus is the oxidation. So we're going to put copper was solid, and we're going to put an arrow over here showing that it becomes copper 2 plus. And we do have to show the movement of electrons though, okay? So we have to show what happened to the electrons. Now, in the case of an oxidation, this part here lost electrons. So the electron's gonna be on the product side because you're sort of releasing the electrons. So Cu becomes Cu2 plus, and it became that because it released 2 electrons in the process. Whereas silver, the reduction, so silver was 2Ag plus Aq produces 2Ag solid. So 2Ag plus became 2Ag by gaining 1 electron. Now the thing is though, that's 1 electron per Ag. So there's 2 electrons here. You sort of want to make sure that the charges are balanced in the end. So this will be 2 electrons and this will be 2 plus, that becomes 0. And this is 2 plus and this is 2 electrons, that becomes 0. The idea is that your half reaction should have the same number of electrons because if you think about it, whatever was lost in the oxidation, so if that's 2 electrons total, it must be gained in the reduction, 2 electrons total. It's a transaction, okay? So if 2 electrons are lost by something, then 2 electrons must be gained by something. And so this is an oxidation half reaction, and this is a reduction half reaction. To remember what oxidation is and what reduction is, there's several tricks that are used. So for example, oil rig is a great trick. Oxidation is loss, that's oil, and then reduction is gain. You can also have Leo the lion says gur. Leo is loss of electrons is oxidation. That's Leo, and then gur is gain of electrons is reduction. Then there's Elmo. I think that one means electron loss means oxidation. So if you like Elmo, you can remember that one as well. There's a lot of different tricks you can make up, mnemonics, try to make up your own to be creative. But these ones have been working for a long time, so you can try to use these ones as well. So we're going to try a sample problem now. We're going to take a chemical reaction. It's already given to us balanced. Keep in mind, it may not always be balanced. You'll have to balance it on your own sometimes. But in this case, it's already balanced and determined for us, another single displacement. What we're going to do is we're going to take this and separate it into half reactions and illustrate why they're half reactions. So first we'll do our net ionic equation. So we'll have our Al solid plus our 3 silvers from here that are in their ion form because they're aqueous and they're from the periodic table. The charge is plus. Plus are also, there's a 3 there, so that applies to this as well. 3 nitrates, also aqueous because they're dissolved in there, and it's minus, that's a polyatomic ion. Then on the other side, we have the Al, so we have Al 3 plus from the periodic table, it's aqueous, it's dissolved in there, plus 3 nitrates as well, aqueous, dissolved in there, and then plus our 3 Ags solid. And so what we need to do now is we need to write the net ionic because we want to try to separate, we want to try to see more clearly what the oxidation and reduction reactions are. So we'll see what repeats on both sides. It looks like it's the NO3 minus here, but but everything else seems to be different in some way with charges. So our spectator ion is the NO3 minus, so that comes out, and then we're left with this net ion equation of Al solid plus 3Ag plus Aq produces Al3 plus Aq plus 3Ag solid. So spectators are out. They're still included in the react. They're still included in the beaker. They're still there. They haven't disappeared. We're just not focusing on them, right? We're focusing on the key players in this event right now, and it's these ions and these metals. So what we're going to do is we're going to separate these into half reactions. And honestly, you don't even need to know which one is oxidation and which one's reduction right now. You can just separate into the two half reactions. So we're going to have Al solid, and I'll put an arrow to show Al 3 plus Aq. And then for the other one, it's going to be 3Ag Aq. I'll put an arrow. I'm saving some space because I'm not sure where the electron's going to go yet. We'll produce 3Ag solid. And so I'm going to start off with my aluminum. I notice that aluminum with the charge of 0 becomes aluminum with a charge of 3 plus. So that means that aluminum with the charge 0 to become 3 plus must have lost electrons, specifically 3 electrons. So that means that this is the oxidation, right? Oil rig, oil. This is the oxidation. And so the oxidation, the electron has to go on the product side, so it lost 3 electrons. And for the reduction, as you know, whatever electrons were lost must be gained by the other component. So that means that this one was 0. Oh, whoops, no, I forgot here that this should have a charge. So if you were probably screaming, there should be a charge there. This is a positive 1. So as soon as positive 1, it became 0. So that's gaining 1 electron, but there's 3 silvers there. And it should be the same number of electrons lost, right? So we're going to put 3 electrons over here. And because it's a reduction, that means that the electrons are on the reactant side. So this is the oil rig. This is the reduction. So what we did in this video is we separated reactions into half reactions. It's still part of the same reaction, but we're just separating them to kind of analyze which part is the oxidation, which part is a reduction. And so you can do that by creating a total ionic equation, converting it into a net ionic equation, and then analyzing what happens based on charges and putting your electrons in the right spot based on the fact that you have oxidation, losing electrons, and reduction, gaining electrons. In the next video, we're going to take a look at terms called oxidizing agents and reducing agents. But for now, understand the concept of what it means to be oxidized, what it means to be reduced, how to create half reactions, and how to identify which reaction is the oxidation half reaction and which one is the reduction half reaction.